today I want to talk a little bit about how Status Go interacts with Go Ethereum and what does it mean for dApps and for Status React and Status clients in general. So first, I want to talk about a little bit about high-level architecture. So in general, we can see that both Status React and dApps, they mostly interact with Go Ethereum the same way. They're both using the Web3 APIs, except Status React, because it's sort of a trusted source. It also have access to some more like a private API. But so like the vast majority of the functionality goes to the same channel for both Status React and dApps. And essentially what it does is, so both dApps and Status React, they have this Web3 JavaScript library that we inject our custom provider in, which isn't using HTTP or anything like this. So it essentially, what it does, it's called this native RPC method. So this one is a native library. And so this provider just called this method. So essentially, when you call anything in JavaScript that looks like web3.ethereum.send transaction, it actually gets translated into an RPC call in JSON with the method name called something like Ethereum_send transaction. So, and that's what I want to focus in the first part of this presentation on. So essentially, the whole presentation would be like a little bit of theory of how Go Ethereum works, then how we work with Go Ethereum, like on top of it, and then a little bit of conclusions. So let's start. So a little bit of disclaimer here. So there are multiple implementations, even the official ones of the Ethereum client. There's like C++ implementation, there is Go implementation. So what I will say will be deeply technical and specific to Go Ethereum because we use it. If it's implemented differently in some other clients, well, it can be implemented in any way. So as I promised, there is this call to some RPC method that actually sends transaction, and you see that it's sort of divided into two parts. So one part is Ethereum, another one is send transaction, and it's like, it's not something random. It's actually divided into two parts. One of this is a part that tells which service do we call to. So this one is service. And another one is a method inside this service. So, and you probably haven't heard this word before. So what is the service? What is this service? And to explain what the service is, I will tell that the node, the thing that we launch, is by itself, it does very little. It sort of discovers other nodes, can connect to them, and does some very basic stuff, but it doesn't do any like business logic. It doesn't create blockchain by itself. It doesn't interact with blockchain. It doesn't send messages and stuff like that. So everything that the node does, so you can think about it like as a clear canvas, right? So you can put anything in it. So to actually do some work, node has to have something, and the something is services. And each node can have multiple services running on it. And one service might be like Ethereum blockchain implementation, and another service might be a Whisper, for instance, implementation, and the third might be something like Swarm or something else, really. So it can be anything. And then each service is actually registered within the node, and there is some registry of nodes, and each service is registered, and it registers its own namespace, like each one of this. And to do that, each service, whether it's like some built-in service or something that's provided with Go Ethereum, something that we built, it has to provide this method called APIs that actually returns a list of things that has namespace names in it. So essentially, in here, we registered one service with the name called SHHEXT. Okay. So, but the service name is just like the first part of the method call, as you remember. So where does the second part come from? And it's actually, each service, it's actually describes some methods. And you see that their names are translated like this in here. And these methods in Go Ethereum again, they are discovered dynamically using reflection. So essentially, if you have an API that has SSHX somewhere, and it has this API object that is registered under this name. And this API object, as you see here, it has a post method. So that means that when the node is launching, it will go through all the registered services and figure out, oh, this service, it has this name. So it will create this name for it and register it somewhere and make it available. So in real life, things are a little bit more complicated because each service, it can, as we see, register multiple namespaces that might or might not be the name of this service. And within these different namespaces, it also can register methods with the same name. But to make things even more complicated, you can register, let's say, your own service in here. And in your own service, you can also write to the same namespace as was created before by another service. And you can actually create another method with the same signature. And there will be a clash of signatures. And as far as I'm aware right now, the last one actually wins. So the one that registers last, so you sort of can override this method with your own services. And that's basically how Go Ethereum works. So the node does very basic functionality, and then it has, for instance, some Ethereum service that implements blockchain, and you might also run like Whisper service on it and stuff like this. So it's very composable and made from different small things that you can compose together. So now how we use it in Status Go, essentially to do our job. So first, that's an overview. It's pretty tricky to look at. So I hope that after the next few slides, you will understand much more on this picture. So what's important right now that we have two modes of operation here. And that's the most important thing that you should learn from it. And so these two modes, they actually, if you go into the status app in the UI, the only difference between these two modes is actually this suffix. So you might have, okay, we have mainnet with RPC, or just mainnet, or like Ropsten with RPC, or just Ropsten. So that's how the modes look. And there are two of them. So one is RPC with upstream, and another one is light Ethereum mode. And I'll start with this because it's a bit simpler to explain how it works. So what LES stands for? So actually, Go Ethereum provides two implementations of Ethereum node of the blockchain service. And one is called the full node implementation and called ETH. And another one is the lightest Ethereum service, and it's called LES, and that's the one we use. The main difference between these two is that this one doesn't really store that much data, so your data storage for the blockchain won't grow to like hundreds of gigabytes of data, and it's a little bit lighter on the CPU and stuff like this, so that's why we use that one. So essentially, when we just launch a LES node, so the naive approach would be just, okay, we have a node, we already have a LES service. Yeah, we need to have a Whisper to do messaging, then we have a LES to interact with blockchain. And yeah, that will be fine. It will work, except there we get one problem. Because sometimes you want to send transactions, and if you're making some kind of a client app, you probably don't want to this client app to just be able to send transaction without you even knowing, or some third-party apps sending transaction without you even knowing. So we need to have some UI confirmations for some of the operations, usually like send transaction or sign something. So for these operations, we need to show some kind of a pop-up in the UI and tell that, okay, do you really want to send this much money to this person or don't you? So, okay, this is a problem. So how to solve it? Yeah, since we know that our client, for instance, Status React, it calls some methods that we know. So here we just implement some override with the sign request queue signals and some approve decline API. And then this will talk to the node already. So how does this work in detail, more or less? So when, for instance, the client sends some method, for instance, send transaction, it goes to our code. And here we just stop it. We don't respond back. We don't do anything. We freeze the code in here, and we add a sign request to the queue. And then whenever the sign request is added, we send the signal to the UI. So, okay, someone tried to send transaction with this data, and there's like UI. And then the UI, like, or the client of Status Go can show some dialog that tells, okay, from this address to this address, somebody tries to send this much money, like 1.8. And then if everything is fine and user approves it, then it's called the special like approve sign request API. And then it returns back to the sign request, it got approved. And then we actually sign transaction and call the blockchain node or the upstream blockchain node, and then take its result and already return here. So this method, it sort of waits all this process. It doesn't know that anything happens here, and this is like a side channel into our UI, into our application. So that's how we override RPCs. And that's essentially our LAS node, that one that is without RPC. So that's how it works. So we also run some convenience services like extend whisper that we are on, so and register them on node. So they are also available inside this namespace. So, but that's how our LES mode works. What about the upstream mode? What about the RPC mode? So the RPC mode is a bit different. Again, let's start with a super simple approach. We already have this client override, right? So we already have it from the LAS model. We obviously, the whole point on having like RPC is not to run anything locally. So let's not run like anything. So let's not run it at all. And just use this client to just redirect everything to Infura and or other upstream RPC nodes, and then get the response back, which is like a very simple approach, right? Except it won't work because not every RPC operation, it should be forwarded somewhere, because first of all, you probably don't want your private keys to be sent anywhere, and Infura doesn't support anything. Like it supports very limited set of APIs, and it doesn't support Whisper, for instance. So for both security and some reasons like the limitation, technical limitations, yeah, and some convenience reasons, we don't want to send everything forward, because again, for convenience, for instance, if we just need to calculate hash, like there is this method, what's it called, like ESHA3 or something like this. So we probably don't want to have a network request when we do this operation, right? So for that, we did a routing table here that has a whitelist. This has a whitelist of the methods that we actually want to forward to Infura. We basically took the list of methods that it supports and picked something that we wanted and put it like into the remote allowed method. And everything else should be still local. Like every other call should be still local. But And obviously, Whisper is not supported by Infura, and our own extension obviously not supported by Infura. So this we have to run. This is like fine, but we don't want to run light Ethereum at all because we don't want. That's exactly what we want to avoid. We don't want to process blockchain ourselves because that's the energy draining and that's a relatively heavy operation. And it works, except when it doesn't, because some of the apps, they use some special sign. Like this is a very, very common operation that needs to be done because, for instance, CryptoKitties use it to sign in to the service. So, and unfortunately, this method is baked into light Ethereum service. And so if we don't run it, then we don't have this one, which is pretty bad. So, but we still don't really want to run light Ethereum service because the whole point of RPC otherwise won't be satisfied. So what we did, we actually made a patch to light Ethereum to extract this API somewhere to the third place and created a super light service on our own that actually uses the same signing API. So that way we also have the personal namespace exposed even though LES is not running. And there we also have this client override. And that is essentially how our RPC mode is working, right? So it's a little bit more complicated, but yeah, it has its own ups and downs. So, and yeah, that's basically the picture that I showed you in the beginning of the presentation. It should be a bit more clear right now. So we have two modes. One is running the blockchain service itself, another is not, and have to deal with this fact that it doesn't run. Also, it has this RPC overrides for UI notifications for transactions and things. And of course, they all run Whisper and extensions to Whisper that we use a lot. And the conclusions from here are that RPC and LAS, this little RPC prefix means a lot of consequences. So these are two different modes, especially everything that is related to the blockchain itself. It's totally different in both LAS and upstream mode, like RPC mode. And we also have like if, which we never ever implement because it's a full node. So if is not equal to LAS and it's not equal to RPC. And that means that some methods might be accessible or not accessible somewhere. And it's very important that we need to test both modes very thoroughly because something might work in one mode and doesn't in another mode. Something might not work in one mode because of one reason and work in another mode because of another reason. So that's the thing. And essentially, that's all my presentation. So I tried to keep it pretty concise today. So yeah, thank you so much. And if you have any questions, I'm ready to answer. So if there are no, oh, there is a Q&A in here. How is determined when transaction is included in light Ethereum service? Well, I mean, so if I understand you correctly, we just, I mean, user just pick whether he wants to use LAS because we have the settings screen and there you can choose if you use like RPC mode or the normal mode. Sort of, and when you pick RPC, then okay, well, transaction is mined LAS. I guess LAS also downloads blocks as usual. It just doesn't request the whole like tree of transactions. It's just like all the whole information for transactions. So it just downloads the block and just essentially downloads the block header, but not all the block data. And then when the transaction, when it needs some information about transaction, then it's requested separately. I hope I'm not wrong about that.
Yeah, one question about that actually. The glitch we found recently that transaction receipts are not available in LES and are available with RPC. Do I understand it correctly that this is because RPC actually is a full node on the serving end?
Yes, exactly. We call the full nodes on the serving end, and that's the problem that we probably need to fix somehow, because we already have some fixes for, as I showed, we already have some fixes for RPC modes because some APIs are missing. But maybe we need to also add some fixes to LES mode to have something like working, because, well, right now, yeah, since the transaction receipt is always empty, we can't really deploy contracts using LES, for instance.
Yeah, among other things. So we should consider that a bug, not a feature, not an intended way the LES works.
Well, I hope that we can either receive, like, well, yeah, we can work around it. Like on the LES side, sort of a light node side, it might be a feature, but on the status side, that's why the status side exists, right? So we can sort of avoid these limitations of the LES side. So we need to make it work.
Okay, thanks.
You know how status Node.js works? I have feature parity with status native modules. No, unfortunately, I didn't look at status Node.js, and but I can take a look and tell you later. So yeah, the question was about how status Node.js works. To sign messages, you use the Ethereum JS lib. No, we use local features because cryptography is still available. Because as I thought, Node is like, it still has some basic services running on it in any mode. So we, as I showed before a little bit, I'll try to find it. So here, that's where we sign transactions. So somebody sends a transaction, it goes to RPC, blah, blah, blah. And then we actually sign it and call it send raw transaction. So we actually send a signed locked transaction to the network upstream and things, because signing features are still available to us. So and it uses Go Ethereum essentially. So, yeah, if hope I answered everything. So if you have more questions, obviously just ping me on Slack and I can tell you more. And if you want to know something specific, because I didn't cover a lot of things here, like what's like private RPCs versus public RPCs, how the security works there, or other stuff. So I can make another short presentation about how that works specifically. But yeah, this one is more or less an overview of how we work. So yeah, if you have questions, then ping me on Slack, or maybe write if you are not on our Slack, if you're not the core contributor. But I also try to answer on Riot. So yeah, thanks, and have a nice weekend, everyone.